All right, there you go. Our objective, determine the slope and y-intercept, if possible. I know you can read, but just in case you can't read my writing, then I did want to at least say it to you guys. So determine the slope and y-intercept if possible. You're going to be presented with different equations, and you're going to try and identify, well, what's the slope and what's the y-intercept? Well, let's say you're given an equation that looks like this. Based on your background, you might be tempted to say that, hey, you know what? The slope is going to be 4 because I always remember that the coefficient on x is the slope. Okay, that's only true if your equation is solved for y. So for this example, which I meant to call example 1, there we go. Before I can identify that the slope is, whatever it is, and the y-intercept is whatever it is, I need to solve this equation for y. Get y by itself, isolate y. All right, so I'm going to leave negative 3y here. I'm going to subtract a 4x to the other side and add a 9. So I'm going to do 2 steps in 1. So I want to subtract negative, or I want to take away 4x. So from a 0 that's here, and then I'm going to add a 9 to both sides because it undoes it undoes the subtraction of 9, so it ends up like this. All right, let's divide everything by negative 3. I think some teachers would have you put negative 3 underneath all the different terms, create like individual fractions, but we can just do it this way. Doesn't matter. Okay, but I am going to want to separate it here. I want to stack and put negative 4x over negative 3, and then I want to simplify that. So that's going to become positive 4x over positive 3. But right here, when I put 9 over negative 3, I'm going to get minus 3. All right, we're good to go. We can identify the slope. The slope is going to be the coefficient on x. Well, that's a fraction. That's 4/3. And the y-intercept, when the equation is solved for y, is the constant value here. So and we call that b. B is negative 3. So there's your slope and y-intercept. And again, remember, this might come out messy, but I can tell you if I'm with you in class and I'm writing on notebook paper, it's very neat and organized. So as you're taking notes, make sure it's neat and organized too. Okay? So here's example 2. Same objective. Determine the slope and y-intercept if possible. And don't you know I'm going to throw one at you where, it might not be possible. All right, well, how am I going to get this equation to look like, this over here where it's y equals when I don't even have a y equals? Okay, well, I'm not. Think about what this graph is. This is really an easy problem, not meant to confuse anybody, but this is just a vertical line. Always use your tools, and one of your tools is to draw a picture to help help you in your understanding. If I had the vertical line x equals negative 6, okay, there's no getting this equation solved for y. Let's just visualize that the slope is, well, it's not equal to anything. It's actually, I'm going to put down here, I need to use the erase feature. M is undefined. All right, and what's the y-intercept? What is b? Meaning, when you look over here, if this is the, x-axis and this is the y-axis, am I ever going to cross through the y-axis? No. So b equals none. Or b, I'm going to cross this off now. If I had an eraser and I was in class, that would be gone. This looks too messy. B, I'm just going to put none. That was easy. That was the special case. All right. Now let's go to the next objective. We're going to determine whether the lines L sub 1 and L sub 2 are parallel, perpendicular, or neither. So this is a reminder for you too about this content. All right, well, 2 lines that are parallel have the same slope, the m values are the same, and 2 lines that are perpendicular have opposite reciprocal slopes. And when I look at two slopes, if the slope values are not the same, or they're not opposite reciprocals of one another, then the lines are neither parallel nor perpendicular. All right. So this is just notation that keeps, the lines straight. All right. All right, let's say that line 1, and this is going to be a colon here, contains the two ordered pairs 3, 6 and -6, 0. And let's say that line 2 contains the ordered pair 0, -1 and 5, 7/3. All right, now think about what you could do. You could actually plot these 2 points and connect them. Then you can plot these 2 ordered pairs and connect them, and you can kind of let your visual help you decide whether or not the lines are parallel, perpendicular, or neither. It might be difficult, but we're going to go ahead and solve it analytically. But I mean, a graph would certainly help too in your understanding. So I guess we have to find the slope of line 1 and the slope of line 2. All right. All right, so I'm going to kind of come over here and kind of do this little squiggle here because I want to put my work over here this way because I'm running out of room down here to do my last problem. All right, we're going to find slope, so that's M. Okay, so, but slope of what? Let's keep it organized. I'm going to do a subscript here of L sub 1. It just kind of keeps everything organized. Remember what I said when we found the slope between two lines earlier? Okay, you might want to label your ordered pairs. So this for line 1 would be x sub 1, y sub 1, x sub 2, y sub 2. Okay, don't get this confused. I mean, that's at line 1, but these are the 2 points that are on there. So, and then this is x sub 1, y sub 1 on line 2, and the second x value, the second y value on line 2. All right, so over here, I'm going to find the slope of line 1. So the difference of the y's, you could write the formula down if you wanted to, but looking at the time and space, I think this is a pretty easy concept. So let's do the difference of the y. So 0 minus 6 over x sub 2 minus x sub 1, what? Negative 6 minus 3. So look at my work here. I'm bringing down the slope in L sub 1 every time. It's just neat and organized. So that's negative 6 over negative 9. All right, well, negative 6 over negative 9 is going to simplify to positive 2/3. Okay, look at my little arrow. This is an organizational thing that I'm kind of formatting. I'm kind of modeling for you. Okay, now let's find the slope of line 2. I meant to put a 2 here. Difference of the y. So in the numerator, I'm going to have 7/3 minus plus 1. And in the denominator, x sub 2 minus x sub 1, so that's 5 minus 0, so that'll just be 5. All right, so the slope of line 2. I don't know what keeps happening to my little 2 there. Equals. All right, so you know that 1 whole should be turned into 3/3. Because 3/3 plus 7/3 makes 10/3, and the denominator is 5. This is what we call a complex fraction, so we're not going to leave it like that. It's just not finished, simplified. All right, let me remind you that you could make this 5 over 1 in the denominator. I don't know how you learn to divide fractions, but a lot of students remember keep, change, flip. I don't know. Keep the numerator, 10/3, okay. Change the sign of division to multiplication and reciprocate, or hence flip, and multiply by 1/5. If you do that, then you can cancel. Divide out a factor of 5, and you end up with 2/3. All right, so at this point, you don't want to just abandon this problem. You want to look at your two slope values and go, hey, you know what? They're the same, so my two lines have to be parallel. So let's respond okay, to the question. I would come down here and just say L sub 1 and L sub 2 are parallel. If you were asked to justify, you could say because the two slopes are equal. But at this point, you've probably satisfied everything that's requested of you in the problem. Okay, one more objective. All right, and I know poof is right there, but it saves time because you can write faster than I can write with this pen. Our last objective, write equations. Oh, in slope-intercept form of lines through the given point, and A parallel to the given line and B perpendicular to the given line. So obviously you need a point and a given line. All right, so you encounter a problem like this. And here's your ordered pair. All right, let's say they give you this equation right here. All right, this equation does not pass through this point right here. I mean, you could solve this equation for y and notice that it doesn't pass through this ordered pair. Okay, but our objective is to find an equation of a line that's parallel to this line, but goes through this point. So write the equation. So remember our two choices, in slope-intercept or point-slope. Well, we don't have a choice. It told us slope-intercept. So, all right, I guess the first thing I need to do is figure out what is the slope of this line, because a parallel line has to have the same slope, and a perpendicular line has to have opposite reciprocal. So I guess what I'm going to do is I'm going to take this equation over here and I'm going to solve it for y. So I'm going to subtract a 4x. Cleaning this up, we're going to get positive 2x minus 3/2. Okay, and the only thing that really matters in that equation that we just solved, I'm back, is what the slope value is. All I care about is not this y-intercept right here. All I care about is this slope value. So circle it and put m equals 2. All right, I'm going to do part A first, and then I'll wrap around and come up here and do part B. So here's part A. The point is 2, 1, and the slope is 2. Let's write an equation of a line having this point, passes through that point, and has the same slope as this line right here. And we're going to do slope-intercept. Okay, this is one way. Let's write down the formula. If you're going to use slope-intercept, okay, then the y and the x need to be replaced with some values, and those values are the ordered pairs. It's just so slow. So this is going to be x, and this is going to be y. It's not going to be x sub 1, y sub 1, because that's not what's in the formula. In this formula, it's just y and x. It's kind of a minor detail, but you know, we want to not confuse anybody here. Okay, let's insert 2, 1, the x and y coordinate, and 2 for the m in here, because what I'm going to find then is b. And then I'll be good to go. So 1 equals 2, that's this 2, x is also 2, and then plus b. So this results in 4, but I'm going to subtract 4 to the other side, so b is going to be 1 minus 4, negative 3. So basically I'm finished, because now I'm going to rewrite the formula y equals mx plus b, but where m is, I'm going to customize it and put it in 2, and where b is, I'm going to replace it with negative 3. So this should be a y. 2 goes here, x, and the b is minus 3. So this is an equation that's parallel to the given equation, but passes through the point 2, 1, and this equation is in slope-intercept form. I don't know where the 2 went, but we better bring it back. Okay, I'm going to come like way up here maybe, just in case I need extra room. All right, I have to still use the same 0.21, but now my slope has to be a value that gives me a line that's perpendicular to this line. All right, so, well, the slope that I'm going to use for this question isn't going to be, what was the slope? It was 2. It's got to be the opposite reciprocal, or -1/2. And we're going to follow the same technique that we did here. I'm not going to use a different color, but you know this is X and this is Y. So I've got 1, 2, 3 things that are going to allow me to find the y-intercept. So y is 1, slope is -1/2, x is 2, plus b. Well, that's convenient. This is going to be nice. That's going to be -1. So 1 equals -1 plus b. Add 1 to the other side to isolate b. Okay, b is 2. So now I have everything I need to write the equation of the line in slope-intercept form. So y equals mx plus b. Well, m is -1/2. Keep the x, and the b value that we did all this work for is 2. So this is the equation of a line that would be perpendicular to this given line right here, but it also passes through the 0.21. Okay, so in case you've forgotten any of this from Algebra 1, I thought I'd put this video together for you to kind of help recall some of the information. So that's it. See you again.